All right, sorry, got cut off by that 15 minutes max capacity. So here's the rest of that last question that we are working on. So we started with 1 over the volume to place our liters on the bottom like we needed. We then went ahead and used our ratio so that we could place that moles of ammonium ion. We then used the molar mass of the ammonium phosphate, which we flipped so that we could cancel moles of NH4,3PO4. And then the last unit we need to get rid of was the grams over here. So we used the mass to be able to help us get rid of our grams. Okay, so in our calculator, we're going to do 1 divided by 0.25 times 3. You can divide by 1 if you want. You can then times by 1 if you want. Then divided by 149.12. Then times that 0.00135. And if you want to do that last divided by 1, you can. And you should be getting 1.09 times 10 to the negative 4 once you round 4 significant digits. So next thing we're going to look at is how you can calculate mass and volume from a concentration. Okay, so first example, a solution of calcium sulfate has a concentration of 0.0135 moles per liter. The student takes 65 mils of this solution and evaporates the solvent. What mass remains in the evaporating dish? So a question like this, I'm going to look at it. There's nothing in it about ions, therefore I do not need to write a dissociation equation, right? That should always be my first decision is, do I need a dissociation equation or not? Like we talked about in the last lesson, that is based off of, is it talking about ions? This isn't talking about ions, so we don't need to worry about it, okay? So things that we have been given, right? Because like we've talked about our steps, first thing we want to do is write out those givens. So we have been given the concentration of that calcium sulfate as 0.0153, I missed the one, moles per liter. Okay, other thing we have been given is the volume, right? We were told it was 65 mils, so we know that the volume is 0.065 liters. Okay, we're going to need molar mass, and the reason we know we need molar mass is we're looking to find mass, right? And mass requires grams, and if you look at your units, this is moles, this is liters, this is liters. Right now I don't have any grams, so we're going to go look up and calculate the molar mass for this. So 1 calcium, 1 sulfur, 4 oxygens. We should be getting 136.15 grams. And that will all be per mole. All right, so now we have all of our givens. Go ahead, start doing our unit analysis. Right, so just like any unit analysis, what am I looking for? I'm looking for mass, so that means I want grams. I start with this given, there's no grams. I move to the next one, no grams. I move to this one, finally we have some grams. Okay, the grams also is in the right spot, so we're just going to use that number exactly as it is. So 136.15 grams, and that's going to be per mole. Okay, zoomed in on that, didn't mean to do that. Now we need to get rid of some stuff, right? We don't want to have moles. We just want to have grams. So how we're going to get rid of it? Well, we've already used this. We can't use this again. This doesn't have moles, but this does. So if I want to get rid of moles, because right now it's on the bottom, I need this on the top, which again, conveniently, it's already on the top. So we can multiply by our 0.0153 moles over our liters. Right, so now we're able to cancel out the unit of moles. Okay, next unit we need to cancel out is our liters. Right now liters is on the bottom. So to get rid of liters, we need to put it on the top. So 0.065 liters on the top, and we're just going to put a 1 on the bottom. And then again, go to those units, we look at them, and we are going to eliminate that unit of liters. So when you have a look at those units now, everything cancels except for grams, which is what we're looking for. Okay, so we type that in our calculator. We do 136.15 times that 0.0153 times that 0.065. Significant digits, we can have 2, so we should be getting 0.14 grams for that one. Okay, so calculating mass is kind of the easiest one, I would say, out of all of these, because you don't have to flip anything. It all just works as is. But again, the more practice you have with unit analysis, the easier it becomes. You'll find at first it takes quite a bit of work, but then by the time you get to the end of it, the end of Chem 20, you're going to be like, I don't even really have to think to do unit analysis. Okay, so here's another example. Okay, more or less the exact same type of question. So a student wants to prepare 125 mils of a 2.50 mole per liter potassium nitrate solution. What mass of solute should they use? So givens-wise, we've been given a volume of 0.125 liters. Okay, we've also been given a concentration of potassium nitrate as 2.50 moles per liter. Okay, so when we look at those units, we see that we can easily get rid of liters, and then we just have moles left, but we're looking for mass. We don't have any grams right now. So whenever that happens, we're going to go look up the molar mass. Okay, and molar mass for this one is 101.11 grams per mole. Okay, so same deal as last time. We are looking for mass. We know that the unit we want is grams. We have a look here. There's no grams, no grams. We have grams, so we are going to start with that one. So we're going to do 101.11 grams. And that's going to go over our moles. Okay, we need to get rid of moles because we know mass is just grams. So to get rid of moles, we're going to use that concentration, 2.50 moles, and we're going to put that over a liter. Once we do that, moles goes away. Next thing we need to do is get rid of the liters. It's currently on the bottom, so we need that unit to go on the top. So 0.125 liters. And again, that can just go over 1. And now we can cancel out those liters. And all we're left with is grams, which is what we were trying to find. Okay, so you type this in your calculator. Okay, in your calculator, you should be getting 31.6 grams. So that's basically how the mass calculations work. Nice and simple. There's some practice for you in your booklets that you guys can work through. So now we're going to look at calculating volume. So the difference now becomes they give you mass and concentration, and they ask you to find what that volume is going to be. So here we have what volume of a 0.25 mole per liter solution of sodium sulfate could be made from 3.5 grams of solute. Okay, so we have a mass given to us as 3.5 grams. Okay, we have a concentration of sodium sulfate, which is Na2SO4, and that's 0.25 moles per liter. Okay, we are going to have to go get one other thing. That other thing we're going to have to get when we look at this, right now none of our units cancels, right? We need to be able to be left with just liters, so we need to be able to get rid of grams and moles. That means we need to go to our periodic table and we need to figure out what's the molar mass for sodium sulfate. Okay, molar mass for that is 142.05 grams, and that is per mole. Okay, so this time around, we are now looking to solve for volume. So that means we want liters, and we want liters on top, right? So mass doesn't have liters, but concentration does. The problem, though, is the liters on the bottom, and we need the liters on the top, because otherwise we've solved for the inverse, which is not what we want. So that's okay. It's an easy fix. We're just going to flip that concentration over. So we're going to write it as liters over 0.25 moles. Now we need to get rid of moles. So to do that, The 3.5 grams isn't going to help me, but the molar mass will because it has moles in it. Right now, there are moles on the bottom. So for me to be able to eliminate moles, I need moles to go up on the top. So what we're going to have to do is we're going to have to take this molar mass and we're going to have to flip it so that we wind up with the moles on the top so we can cancel stuff. So we're going to do moles over 142.05 grams. This now lets us eliminate the moles. Right now we have liters per gram, but we don't want liters per gram. We just want liters. So we're going to get rid of grams. To get rid of grams, right now it's on the bottom. We need to put it on the top. So we're just going to use that 3.5 grams. And because there's nothing else associated with it, we're just going to put it over 1. And then our units of grams goes away. And all we have left is liters. So when you go to calculate this one, you do have to be a little bit careful, right? Because there isn't a number up here with the liters. So a lot of the times we talk about not having to use the 1, but this time you're going to have to do 1 divided by 0.25. They're going to divide that by 142.05 and then times by 3.5. Okay, so when we get that, we get 0.0, how many significant digits? 2, so 99 liters. Or if you want, you could even have written that as 99 milliliters. Okay, both are acceptable. The only time we would require you to write one and not the other is if it was like a numeric response and it specifically gave you a unit of liters or specifically gave you a unit of milliliters, or obviously if it was a multiple choice, but then you would know because you would be able to see what units your answers have, okay? All right, so one more example, just to make sure that you feel pretty confident with this. So what volume of a 2.80 mole per liter solution of sodium bromide could be prepared from 3 moles of solute? So still the same type of thing. We're looking for volume. We have been given the concentration of sodium bromide as 2.80 moles per liter. And this time, we've been told how many moles we have. So this is a little different. The other ones were giving us mass. So one of the most common mistakes you guys make is you always want to use molar mass. But in this case, I don't need molar mass. And how I can see that I don't need it is look here. We have moles here. But we also have moles over here. So I can use these to cancel each other out, and then all I'm left with is liters. So getting molar mass is actually going to turn this into something that it doesn't need to be. So we're going to calculate volume. We're looking for liters. Here's our liters, so we're going to flip that over. So we're going to put that liters over 2.80 moles. Okay, to get rid of the moles, we're then just going to times by 3 moles and put that over 1. And then we have a look at units. Moles is gone. We're left with liters. We can go ahead and type that in our calculator. So we're going to do 1 divided by 2.8 times 3. And we get 1.07 liters as our answer. Okay, so that is how you calculate mass and volume from a concentration.